us. You can kindly share the link with friends. Share the link with friends. We're going to answer this question. Then from this question, I will embark on another question which involves the drawing of an ogive. An ogive is a cumulative frequency curve, and we're going to see it later. For now, let me work out this question. Remember, it's good to note what happens in these type of questions, all of them. So we are told that a sample of 100 bulbs, the time taken for each bulb to burn was recorded. Then the table below shows the results of the measurements. We have time in hours, we have the number of bulbs here. So the data is as distributed up here. We are taught to use an assumed mean of 42 to calculate the actual mean of distribution, the actual mean of the distribution. Therefore, I'm going to handle this data in a different way. I'm going to arrange it. I will change these rows into columns so that I may use the space available here to handle the data. Therefore, I'm going to have the time here in classes. I'm going to have time in classes there. This will be the time in classes. So this will be classes. Then the frequencies for the different classes. So let me first bring the classes here. Then I will have a value called x. X is usually the midpoint of the respective classes. Then I'm going to have what we call the deviations T or D. I can use D. D is usually given by each midpoint minus the assumed mean. The deviation of each midpoint from the assumed mean. Then I will calculate something called the FD, frequency times the deviations. Frequency times the deviations. Frequency times the deviations. So what I'm going to start with, actually, instead of transferring the classes here, I'll begin with the frequencies, which are 6, 10, 9, 5, 7, 11, 15, 13, 8. Then we have 7, 5, and 4. 5 and 4. So these are the, because my book, my space here is not ruled. Let me come up with the lines to avoid confusion. Yeah, so that I may be perfect in my work. Remember to subscribe and to share this link with friends. There are very many people who would like to also understand how statistics 2 is handled. There are people who would also like to see how assumed mean can be used to obtain mean. So please share the broadcast with them. Yes, now I've at least opened up my table very well. So now with all the frequencies there, I'll get the midpoints. Instead of writing the classes twice, I can simply get the midpoints direct. So from 15 to 19, I add and divide by 2, 15 and 19. Then I divide by 2. And this is giving me 17 as the midpoint. The midpoint is 17. Then we have the next class is 20 to 24. When I add, I will get 44, sorry. The midpoint will be 22. When I add 25 and 29, I'll get 54. So the midpoint will be 27. When I add 30 and 34, I'll get 64, a midpoint of 32. Then we will have 35 and 39 giving us 74. So 37 becomes the midpoint. We have 40 and 44 giving us 84, a mid of 42. Then we will have 45 and 49 giving us 90, 45 and 94, so 47. Here the midpoint will be 52. The midpoint here will be 57. Then in the next class, 60 and 64 will be 62. Then we have 65 and 69, so 67 becomes the mid. Then the last class here, 70 to 74, 72. So we have all the midpoints now. We have all the midpoints. I've said instead of transferring the classes, I've used them as where they are. So now the next will be deviation of each midpoint from assumed mean of 42. Therefore, I will take 17 minus 42, negative 25. Then I will multiply it with f, which is negative 150. The next will be 22 minus 42, giving me negative 20. I multiply it with a frequency of 10 to give me negative 200. The next will be 27 minus 42, giving me negative 15. And I multiply with a frequency of 9. So negative 15 by a frequency of 9, this gives me negative 135. Then the next I'm going to have 32 minus 42 giving me negative 10. I multiply with a frequency of 5. This will give me negative 50. The next will be 37 minus 42 giving me negative 5. By a frequency of 7, this will give me negative 35. The next is going to be 42 minus 42 giving me 0. Multiplied by 11, this will still give me 0. The next will be 47 minus 42 giving me 5. 5 by 15 will give me 75. The next will be 52 minus 42 giving me 10. 10 multiplied by 13. 10 by 13 will give me 130. The next will be 15. 15 multiplied by 8 will give me 120. Yeah. Then we will have 62 minus 42 giving me 20 by 7, the frequency, to give me 140. Then we will still have a 67 minus 42 giving me 25. 25 by 5 will be 125. 125. Then we will have 72 minus 42. 72 minus 42. 72 minus 42 giving us 30 by 4, 120. So now we can get the summation of FD. Remember, we want to get mean using assumed mean. Therefore, the first thing to get here is mean. mean using assumed mean, because I will use this space. Okay, let me structure it this way. So mean using assumed mean using assumed mean will be given by the summation of fd divided by the summation of f, then I add the assumed mean. So I will need the summation of f of d divided by the summation of f, and because the summation of f has not been calculated, I can work it out here and call it cumulative frequencies. So cumulative frequencies will give us the summation of f. The first frequency is 6, the second one is 10, so 16, the third one is 9, so I'll get 25, the second one is 5, so I'll get 30, 37, then I add 11, 38, sorry, 48, then I add 15, I'll go to 63, then I'll add 13, I'll go to 76, I add 8, I'll go to 84, I add 7, I'll go to 91, I add 5, I'll go to 96, yeah, 96, then I add 4, I'll go to 100. So the summations of f is 100, but now summations of fd have to be worked out using the calculator. Therefore, I'll need negative 150, negative 200, negative 135, negative 50, negative 35, then I add 75 plus 130 plus 120 plus 140 plus 125 plus 120 finally. This is giving me 140. So I will take 140. This is 140. So I'll take 140. I divide it with 100. Then I add 42, the assumed mean. So mean is going to be, when I divide this by 100, then I add 42, I'm going to get 43.4. This is the mean, the actual mean using assumed mean. That is the actual mean using assumed mean. Now the next is to get standard deviation of the distribution. For us to get standard deviation S, we get the square root of variance, which is s squared, and this will be the square root of, we need to get f of d squared divided by f, then minus f of d out of sum of f, this is summation of f of d, then this one should be squared. This one independently should be squared. So with this formula, I'm going to get what we call standard deviation after getting variance. Therefore, I need to get f of d squared. So in this case, I'll get f of d squared. F of d squared. So I will square the d, 25 squared. Then I multiply it now with f. F is 6 in that case. So I'm getting 3750. The next will be negative 20. So I square it. Then I multiply it with f, which is 10. This gives us 4000. The next will be 15. I square 15. Then I multiply now the squared 15 with 9, which is the frequency there. This gives me 2025. The next will be negative 10. I square to get 100. Then I multiply it now with 5 to give me 500. The next is going to be negative 5. I square it, I get 25. then a frequency of 7. So 25 by 7. This gives me 175. The next will be 0. So I square 0 and I multiply it with 11. It will still be 0. It will still be 0. Then 5 squared, 25 by 15. This gives me 375. The next will be 10 squared, which is 100 times 13. 1300. The next is 15 squared to give me 225. Then 225 I'll multiply it with a frequency of 8 to give me 1800. The next is going to be, this is a 20. So I square 20 to get 400. Then I'll multiply now the 20 with 7, which is the frequency there, giving me 2800. The next one is at 25 squared, 625. I multiply 625 by 5. This will give me 3125. Then finally, I'm having 30 squared, 900. Then I multiply 900 with the frequency here, which is 4, 3600. So I'll need to get now the summation of fd squared. The summation of fd squared now. I'll need to work out this summation now. Fd squared. Therefore, I'll begin with 3750 plus 4000 plus 2025 plus 500 plus 175 plus 375 plus 1300 plus 1800 plus 2800 plus 3125 plus 3600. This is going to give me 23,450. Therefore, that is the figure I'm going to use in this substitution. So I'm going to have 23,450 out of 100. Then I subtract sum of FD out of sum of F squared. Sum of FD has already been calculated here. It's 1.4. Therefore, 1.4. But now I square it. 1.4 squared. Therefore, variance is going to be, when I divide this by 100, then now I subtract 1.4 squared. This will give me 232.54. This one is called the variance. For me to get standard deviation, I'll need square root of variance, 232.54. So this is going to give me, when I obtain the square root now, this will give me 15.25. This is to 4 significant figures. So this will be the standard deviation in 4 significant figures. Finally, I'm told to calculate the quartile deviation. Quartile deviation. For us to get quartile deviation, which is also called the semi-interquartile range, I'll need to get Q3 for this data minus Q1 for this data divided by 2. Therefore, let me begin by working out Q1. For me to work out Q1, I will need lower class boundary plus a quarter of the total data. So the total data divided by 4 minus cumulative frequency before, divided by frequency of this class having Q1 times class width. So mine is to first of all identify the class having Q1. The class having Q1 is the class with 100 out of 4. This is 25. So the class with the 25th bulb, because we are dealing with bulbs, the 25th, according to cumulative frequencies here, according to cumulative frequencies, the 25th bulb is accommodated in this class. So this becomes our Q1 class, and it is the class with a frequency of 9. So this is the class. 25 to 29. So the lower boundary is 24.5. 24.5. So I substitute 24.5 plus, when I take 100 over 4, I will get 25 minus the cumulative frequency just before this class is 16 and the frequency of this class is 9. Then the class width itself is from 24.5 to 29.5. I'm having 5. So the class width is 5. So the Q1 value is going to be 25 minus 16 divided by 9 is 1 times 5. I get 5. So 24 point, let me redo that. 25 minus 16, I'm getting 9. So I'll divide by 9 to get 1 times 5. This is still 5. So 5, I'm going to add it to this and I'll get 29.5 as the Q1. Let me get Q3. Q3 will be lower class boundary plus 3/4 of n minus cumulative frequency before divided by frequency of the class multiplied by the class width. Therefore, 3/4 of the data will be 75. 3/4 of 100 is 75. Therefore, the cumulative frequency of 75 will be here because this is 63, 76. So the 75th is going to be in this case. Therefore, the class is the class with a frequency of 13. This class. This becomes our Q3 class. So if the limit is 50, then the lower boundary is 49.5. Therefore, I have 49.5. I add 3/4 of data, which is 75. I subtract cumulative frequency before, which we have seen as 63. Divide by frequency of the class, which is 13. Then I multiply this with a class width of 5. This is going to give us the Q3. So Q3 is going to be obtained by, when I take 75 and I subtract 63, then I divide by 13, then I multiply by 5, then I add 49.5. This will give me 54.12. 54.12. Therefore, now I can get quartile deviation, whereby I will need Q3 minus Q1 and I divide by 2. So 54.12 out of 29.5, then I divide by 2. Just to mention, Q3 minus Q1 gives us what we call interquartile range. But now when we divide it by 2, we get semi-interquartile range, or rather the quartile deviation. In this case, it will be 12.31. 12.31. So that is how we answer such a question. We can briefly check another question here, which involves the drawing of an ogive. The drawing of an ogive and the use of the ogive in the calculation of a few things. Therefore, with the data here, remember we've already worked out mean using assumed mean. We'll need the summation of f of d divided by the summation of f. Then we add the assumed mean. This will give us the actual mean. Again, we should know that the deviation will be given by each midpoint minus assumed mean. Then we can work out just like in the former question. But for now, allow me focus on the ogive, whereby we are told on the grid provided, draw the cumulative frequency curve of the data. Cumulative frequency curve is also called the ogive. An ogive should behave like a stretched S, like this. So that is what we should expect. So I'm going to work out the cumulative frequencies for this case. We are beginning with 3, the first case, plus 4 we go to 7, plus 10. This is going to be 17 plus 12, 29 plus 8, 37. And now plus 3, we get 40. So these are the cumulative frequencies. Cumulative frequencies. So we draw cumulative frequencies against class boundaries. Cumulative frequencies against class boundaries. So I'm going to have my cumulative frequencies here. Cumulative frequencies will be here. So I will draw the cumulative frequency on this side, then the class limits at this point. The class limits on this side. So for me to have a good scale of the cumulative frequencies, I'll need to begin from 0, then I go to 5, then I go to 10, then I go to 15, then I go to 20, then I go to 25, then I go to 30, then I'll go to 35 and 40. So a scale of 5 is going to favor us in the drawing of this cumulative frequency curve. After drawing that, now we can come to the other side. I can see the least boundary is 40. Okay, we have a limit of 48 to 52. So that means the boundary there is going to be 47.5. So I'll begin with 47.5. Then I go to 52. Yeah, 52.5. Then from 52.5, I'll go to 57.5. Then I add 5 again to 62.5. Then I go to 67.5. Then 72.5. Then 77.5. So I have all the limits now. I have all the limits now stated there. I have all the limits stated according to this data. Therefore, I'll start with 3 against the upper limit here, 52.5 against 3. So 52.5 against 3. 3 is going to be somewhere here. Then 57.5 is against 7. 7 is somewhere here. 62.5 is against 17. So 17 is somewhere here after 15. Then we go to 67 against 29. 67.5 against 29. So 29 is somewhere below 30. Yes. The next will be 72 against 37. 72 against 37. So that 7 will be somewhere here. Somewhere there. The next is going to be 77.5. This will be against 40. This will be against 40. So now we can draw. We can now draw. We can now draw. Can now draw this curve. Can now draw this curve. So it's going to be from this point. And as we said, an ogive should simply behave like a stretched S. A stretched S. And as we can see, it is featuring out very well. So this is going to be our cumulative frequency curve, or rather the ogive. That is how the ogive will be. Now there is a question I can see we should answer from this ogive, and we are told to use the graph to estimate the semi-interquartile range. Semi-interquartile range is what we call the quartile deviation. So we need Q1 we need Q1, the value at Q1. So remember, Q1 will be given by a quarter of this data, and a quarter of 40 is 10. Therefore, when we go to 10 on the cumulative frequency side, we will draw a straight line until we intersect our curve. Then now, after intersecting the curve now, we go down now. Through that, we go down until we read the value there. So Q1 will be here. So Q1 is going to be, if this is 57.5, this will be 59.5. So it's going to be 59.5. The next thing is we'll get Q3. 3/4 of 40. 3/4 of this data is going to be 30. Therefore, 30 and we move across. 30 and we move across until we intersect the curve. So this will be the point. Now we move downwards until we read that value. And Q3 is going to be at this point. So my Q3 is 67.5. 67.5. So Q3 is 67.5. Therefore, now with Q1 and Q3 identified, we need to get now semi-interquartile range, which is given by Q3 minus Q1 divided by 2. Therefore, I'll need to take now my 67.5. I subtract 59.5. Then I divide by 2. Therefore, I will take 67.5 minus 59.5. Then I divide by 2, and I'm getting exactly 4. Therefore, the semi-interquartile range of this data is exactly 4. Thank you for following. I can see David Nduva was alive. Thank you. Was live following. Masimweni, thank you so much for following up. So those who did not succeed to follow the live lesson can still watch the broadcasts later. Thank you, and have a good weekend.